Okay, so now that we've looked at safety and material selection, let's get cutting.
It's important to note that your files must be in Illustrator format, but when you do bring in Illustrator files that are created on other computers, they have embedded within each file some incorrect settings that undermine our workflow. This is why you're required to copy and paste the vector lines from your file into the brand new file created on the laser computer, and I will explain how to do this as we go along. With these lasers you can both etch and cut. We will look at these processes individually, but before we do, it's important to understand the difference between raster files and vector files. Raster files are pixel-based files like JPEGs and bitmaps. Although you can represent lines in these files, the laser machine won't recognize them as lines and won't cut them for you. So, a raster file would be ideal if you want to etch. Alternatively, vector files can carry and represent lines that the laser machine will recognize and cut. Vector lines are lines defined by points with segments or curves in between. They're usually created and stored in vector-based programs like AutoCAD, Rhino, Revit, SolidWorks, Illustrator and CorelDRAW. So, vector files are ideal for when you want to cut. The bed size of the laser is 800mm times 500mm. For this demonstration, I'm using a sheet of 3mm MDF that is 125mm times 75mm in size, and I'm going to demonstrate a vector cut. On the laser computer, open Illustrator. Next, create a new print document with the size of 125mm by 75mm. Now open the file carrying the shapes that you want to cut. Your shapes should always be nested together to minimize sheet waste. Then copy these and paste them into the new document. Now, reduce the line width, or stroke, to 0.001. If your vector cutting lines aren't 0.001, then they just won't cut. Next, lift up the lid of the machine and place your sheet material on the bed. Always place the sheet material in the top left-hand corner, matching the orientation of your Illustrator file, and close the lid. Turn the laser machine on using the power switch on the front face of the machine. It takes a minute or so for the machine to initialize. In Illustrator, select File, then Print, then Make Placement at X equals 0 and Y equals 0. Then select the Setup button, and then Preferences. Then you see the laser print driver window open. Here you will see things like speed, power and frequency, raster and vector, etc. Do not change these settings. All you have to do is select the Advanced tab, then select the correct material number for your job, and then we select Load, OK, and Print. And this will then send your job to the laser. And that's it. It's quite easy and straightforward. On the laser machine display, you will see your job. You may need to use the toggle to scroll up and down through other people's jobs to have your job displayed. It's always a good idea to name your Illustrator files so you can recognize them on the laser display. These lasers focus automatically, so there is no need to manual focus. Once your file is displayed, then press the green Go button and the laser will start your job. Make sure you stay by the machine while it is cutting. Once the cutting is complete, the laser head assembly will move back to its home position and beep once. This is telling you that the job is finished. Leave the lid down for at least 5 seconds and let any gas get extracted. Then take out your job as well as your offcuts and place any unwanted material in the rubbish bin. If you finish your work, then turn the laser machine off and log out of the laser computer. We don't want untrained people coming in after you and using these machines. The process of raster etching is quite beautiful. When the laser software sees 100% black pixel, it gives a zap of 100% power. When it sees a 50% black pixel, or in other words a grey pixel, it gives a zap of 50% power. And when it sees a 0% black pixel, or in other words a white pixel, it doesn't give any power at all. The laser head races back and forth across your sheet material, giving out what we call 300 ZPI, that is 300 zaps per square inch, and recreates your raster image on the surface of your sheet material. You will also notice that whenever there are dark pixels on your image, on an acrylic sheet it will make the surface go white. So, on some materials, a positive image ends up being etched as a negative, and for other materials, a positive image will end up being a positive. You can work out which materials this applies to yourself, and if needed, reverse your image using Illustrator. The etching process is very similar to the process for vector cutting. The bed size of the laser is 800mm times 500mm. Now we're going to perform a raster and vector etch on a piece of acrylic that is 100mm by 50mm, that is 3mm thick. In Illustrator, I'll create a new print document with a size of 100mm times 50mm. Then I open my file carrying a combination of two raster images surrounded by two vector rectangles. One of these rectangles' line width is 0.001 and the other isn't. The laser will treat them differently and we'll see what happens when the job starts. Then copy these and paste them into the new document. Lift up the lid of the machine and place the piece of acrylic on the top left-hand side matching the drawing orientation, and then close the lid. Switch the machine on. In Illustrator, select File, then Print, then Make Placement at X equals 0 and Y equals 0. Then select the Setup button, then Preferences, then select the Advanced tab. Then select the corresponding number for an etch of 3mm acrylic. Select Load, OK, and Print, and this will send this job to the laser. At the control panel, pick your job using the toggle and then press Go. You will then see the laser head sweeping quickly back and forth across the acrylic sheet, recreating the fat vector rectangle and the two raster images on the surface. But it's not recreating the thin vector rectangle with a line width of 0.001. It will leave that until the end of the job and quickly follow that vector path, cutting into the surface but not all the way through. That is vector etching, which is much quicker and more efficient when etching vector lines into the surface of your material. Now you can see the slow raster etching process. Now you can see the very quick and efficient vector etch. Make sure you stay by the machine while it is cutting. Once the cutting is complete, the laser head assembly will move back to its home position and beep once. This is telling you that the job is finished. Leave the lid down for at least 5 seconds and let any gas get extracted. Then take out your job as well as your offcuts and place any unwanted material in the rubbish bin. If you finish your work, then turn the laser machine off and log out of the laser computer. We don't want untrained people coming in after you and using these machines.